next part, that is the physicochemical properties which affect the drug activity. So physicochemical. So it includes both physical properties as well as the chemical properties. So when we take the drug, so that drug, depending upon these physicochemical properties, shows the activity. So what are the physical properties? What are the chemical properties? So the physical property of drug is generally responsible for this drug activity, but the chemical property, that means the chemical changes which can be takes place in a drug. So chemical reactions like chelation, oxidation, neutralization can be takes place with the drug, and it will alter the activity of a drug. Okay, for we have seen phase metabolism. Okay, so if the metabolism rate is more, or more metabolism takes place, or more chemical reaction takes place, what happens? The duration of activity of drug increases or decreases. This activity also decreases. So these are the chemical property which affect the drug activity. Okay, then size of a drug, it also interfere. It also depends, or it also produces the changes in the drug activity. If size of drug is less, so it can show the better solubility and the better activity of drug can be takes place. But if size of drug is more, it is difficult to undergo the dissolution process, so it may show the less activity as compared to the drug. So that is some physical properties and chemical properties, and these properties can affect the drug activity. So what are these properties? So regarding your syllabus, these are the properties. So solubility, partition coefficient, dissociation constant, hydrogen bonding, ionization of drug, redox potential, complexation, surface activity, protein binding, and isomerism. So these are the points are mentioned in our syllabus which affects the drug activity. So I will explain these properties in short which will affect the drug activity. First one is the solubility. Okay, suppose drug having the solubility more in the water, that means if it is more hydrophilic drug, so what happens, it can undergo better dissolution, but it is difficult to cross the membrane for the drug. Why? Because it is hydrophilic, and our membrane, this membrane is the lipophilic membrane, so it is difficult for drug to cross this membrane. But due to its hydrophilicity, it can show the better dissolution rate, or the more dissolution. And in opposite, if drug is more lipophilic, what happens? It will not undergo dissolution, but it can cross this easily, and it will show the more activity. So the drug should have both the activities, or both the properties, that is the hydrophilic property as well as the lipophilic property. So the hydrophilic property is required to show the solubility, or to show the dissolution, and lipophilic property is required to cross the membrane. That's why solubility of drug is important, because for the pharmacist, for the preparation of liquid dosage form, the drug must be soluble, or drug must be come in the solution, it should be dissolved before it absorbed by the body to produce the biological activity, as well as it is required to interact with the receptor. So these are the more importance to the solubility. So how you can enhance the solubility? So you can observe in most of the drugs you find the salt form. Drugs are essentially HCl essence. Okay, so they are generally from the salt form. So by converting them into the salt form, the solubility of drug can be increased. Other method, we can use the co-solvents like ethanol, sorbitol, PG, PEG. Then by using the surfactant, by the complexation process, by altering the structure of molecules. So these are the different process by which we can enhance the solubility of the drug. So the next part is the partition coefficient. So as we have discussed, the drugs should have both the property, that is the hydrophilic property and the lipophilic property. So what is their ratio? In what ratio they are dissolves in the oils or dissolves in the water? That ratio is called as the partition coefficient. So what is the partition coefficient? So it is the property, or it is the physico-chemical properties. It defined as the equilibrium constant of drug concentration of unionized molecules in two phases. So how it is, or in what amount it is present in the lipid, or what amounts it is present in the water. Suppose in a beaker we have taken two liquids, one is the oil, another one is the water. They are immiscible, but when drug is added into that beaker, what happens? Some of the drug part it will dissolve in the water, some of the drug part it will dissolve in the oil. So if we find out what is the concentration of the drug which dissolve in the oil with respect to the concentration of drug which dissolves into the water, so that ratio is called as the partition coefficient. So why it is important? First, for the dissolution to make the solubility of the drug, and second one to cross the barrier or the cell membrane which is the lipophilic in nature. So to get this point, the partition coefficient is important. So which are the factors which affect the partition coefficient? So pH, co-solvent, surfactant complexation, these are responsible to alter the partition coefficient. So partition coefficient means concentration of drug in oil phase with respect to the aqueous phase. So how it is hydrophilic, how it is lipophilic, that can be defined by this partition coefficient. So log P, or the partition coefficient, what it affects? So first, binding to the enzyme, second one, solubility, third one, binding to the metabolic enzyme, absorbance through membrane, binding to the blood tissues or blood or the tissue proteins. So these are depends on the partition coefficient, that is the binding to the enzyme, then their solubility, then binding to the metabolism enzyme, then absorbance through membrane, and finally the binding to the tissue or the binding to the blood. The next parameter which affect the drug activity, that is the hydrogen bond. So what is the hydrogen bond? It is generally a weak bond. It is the dipole-dipole interaction between the hydrogen atom in polar bond with respect to the electronegative atom. Okay, so we know the hydropolar, suppose NH is there, OH is there. So this hydrogen forms a bond with another heteroatom. So in this NH, if another nitrogen comes in the contact, so it forms a bond. So that is the dipole-dipole interaction between nitrogen and hydrogen. Or if this nitrogen comes in the contact with the hydroxy group, it forms a bond. So that bond is called as the hydrogen bond. Generally it is the dipole-dipole interaction, which is the weak bond. Okay, so these hydrogen bonds, they are classified into two types. One is the intermolecular, or second one is the intramolecular. सो एकाच मॉलिक्यूलमध्ये जर हायड्रोजन बॉन्डिंग होत असेल त्याला आपण इंट्रामॉलिक्यूल म्हणतो. दोन वेगवेगळ्या मॉलिक्यूलमध्ये जर हायड्रोजन बॉन्डिंग होत असेल इट इज कॉल्ड ॲज इंटरमॉलिक्युलर हायड्रोजन बॉन्डिंग. So if there is a hydrogen bonding, that is the bonding between the hydrogen and the heteroatom takes place within same molecule, it is called as intramolecular. And if the hydrogen bonding takes place between the hydrogen and heteroatom of different molecules, they comes under the intermolecular hydrogen bonding. So due to this hydrogen bonding, that is intermolecular hydrogen bonding, there is an increase in the boiling point takes place. Hence more energy is required to dissociate the molecule for the vaporization, and hence it's the boiling point increases. So these are the examples where the intermolecular hydrogen bonding takes place, that is the hydrogen from one molecule and heteroatom from another molecule. In case of intramolecular, this bonding or the hydrogen bonding occurs between the atoms of the same molecule. So due to this, there is a decrease in the boiling point takes place. So when intermolecular hydrogen bonding takes place, boiling point increases. Intramolecular hydrogen bonding takes place, hydrogen bond decreases. So this is the salicylic acid. So you can observe the oxygen of COH part and hydrogen from OH. So it is from the same molecule and there is a bonding takes place. This bonding is called as the hydrogen bonding, and it takes place in the same molecule atoms. So it is called as the intramolecular hydrogen bonding. So here also O nitrophenol, this is OH, this is O. So this bonding, it is the intramolecular hydrogen bonding. So these are some examples. What is the effect of hydrogen bonding? So how it affects the activity? So it affects the boiling and melting point. So it affects the water solubility. It affects the strength of acid, spectroscopic properties, surface tension, viscosity also changes, biological products changes, drug receptor interaction also changes. The next one is the chelation or the complexation. So when a drug complex is formed between the drug and the complexing agent, this process is called as the complexation and chelation. Okay. So if the drug molecule is a complex, it will not cross or it will not undergo or go through the membrane barrier, and due to that the activity of drug will decrease or it will decrease the potency of a drug. So if the complexation reaction takes place and if a drug complex is formed, so here you can observe drug and complexation agent. With this the drug complex is formed, and if the drug complex formation takes place, it is difficult for the drug complex to cross the membrane barrier because it is the lipophilic in nature, and hence the activity of drug will decrease. So complexation reduces the rate of absorption of drug, but it will not affect the availability of the drug. So these are some importance of chelation. So we are giving the metal poisoning the antidote. So this is one of the example: dimercaprol, penicillamine, phenobarbital, calcium and NADH complex, which increases the permeability of membrane. Next one is the ionization of drug. So most of the drugs, they are either weak acid or weak base. Okay, so they will exist in either ionized form or unionized form. So if it is present in the ionized form, it produces the protonation or deprotonation, and it will result into the charged molecules. And this ionization of a drug, it depends upon the pK value, that is the pH value.
नमस्कार मित्रांनो, आता आपण हिंदू कॉपर 115चा कॉल घेणार आहोत. सप्टेंबर महिन्याचा घेणार आहे कॉल. आता एक्सपायरी 25 तारखेला आहे या ऑगस्टची, त्यामुळे आपण सप्टेंबरचा 115चा कॉल घेणार आहे. हिंदू कॉपर टाईप केला आणि 115 इथे सप्टेंबर मंथचा दिसते, ऑक्टोबर मंथचा, तर आपण सप्टेंबर मंथचा क्लिक करणार आहे त्याच्यावरती. त्याची प्राइस आहे चालू 6 रुपये प्राइस चालू आहे, बरोबर. आपल्याला कितीला घ्यायचा आहे तो 5.90 किंवा 5 रुपयाला घ्यायचा आहे. तर त्याचा आपण चार्ट पहिल्यांदा बघणार. चार्ट बघितल्यावर आपल्याला समजेल. 5 डेजचा चार्ट बघितला मी. 5 डेजमध्ये हाय किती आहे त्यांचा, हाय आहे 9 रुपये हाय आहे आणि लो आहे तो 5 रुपयेच लो आहे. आणि वन डे चार्ट बघितला तर लो 5.5चा लो आहे आणि हायला कितीला गेले 7 रुपयाचा हाय आहे. आणि याच्यामध्ये क्वांटिटी किती आहे बघायची. क्वांटिटी आहे 4300 क्वांटिटी आहे एका लॉटची. तर आपण आता 5 रुपये 5.6 टाकूया. रेग्युलर ऑर्डर आहे, ओव्हरनाईट नॉर्मल आहे, पुढच्या मंथपर्यंत चालणार. लिमिट ऑर्डर आहे, स्टॉप लॉस वगैरे काही नाही, सेट टार्गेट वगैरे काही नाही. एवढंच करायचं. स्वाईप टू बाय. ही ऑर्डर प्लेस झाली. आता आपल्याला ओपन ऑर्डर दिसते. आणि मी सकाळी 2-3 ऑर्डर एम ऑर्डर टाकले होते, आफ्टर मार्केट ऑर्डर. आणि ते ऑर्डर मी आता बघितले तर त्या दोन्ही पण हिट झाल्या होत्या. या दोन्ही ऑर्डरमध्ये आपल्याला 1485 रुपयाचा फायदा झालेला आहे.
So the next factor which affect the drug action, that is the ionization of drug. So what happens if drug is unionized? Then drug can cross the barrier, that is the cell membrane, or the barrier, that is the lipophilic. So it can enters into the blood circulation, that is the absorption. For that absorption, this part is necessary. But if the drug is in ionized form, it is the difficult for the ionized drug to cross this membrane and to enters into the blood circulation. That's why in our body the different types of drugs, they are absorbed at different positions. So mainly drugs can be absorbed to the stomach also, drugs can be absorbed to the intestine also, but the intestine having the larger surface area, so the most of the drugs it can be absorbed from the intestine. So what is the ionization? The ionization means the given compound it can donate the protons, or the deprotonation can be takes place. So this ionization of a drug or unionization of drug, it depends upon the pH value and the pK value. So when if drug having the good ionization power, it having the good water solubility. But if drug having the unionized form, it can having the good lipophilic properties. So if drug is present in the unionized form, this unionized form helps the drug to cross the cell membrane. For example, you can say the barbituric acid. The barbituric acid is inactive drug. So instead of barbituric acid, we are giving the derivatives of barbituric acid like phenobarbital, secobarbital. Okay, so why we are giving? Because the barbituric acid having the highly acidic in nature. So due to the high acidic in the nature, what happens? It can present in the ionized form, and when it is present in the ionized form, it cannot cross the membrane. It will not enter into the blood circulation. So drugs can be strong acid, it can be strong base, it can be weak acid, it can be weak base. Okay, so what happens if strong acids or strong bases are present? This type of drugs which having the strong acid or strong bases in the nature, such drugs can present ionize in each and every pH or pK value. So what happens if drug is highly, suppose any drug is there which is highly acidic, so this highly acidic drug, it is present in the ionized form. It may be in the acidic pH or the basic pH. कुठलाही pH असेल त्या pH मध्ये दिलेला ड्रग हा आयोनाइज फॉर्म मध्ये असतो. आणि जर ड्रग हा आयोनाइज फॉर्म मध्ये असेल तर तो बॅरियर क्रॉस करू शकत नाही. सेल मेम्ब्रेनचं बॅरियर क्रॉस केलं नाही, इट विल नॉट एंटर्स इनटू द ब्लड सर्क्युलेशन, इट विल नॉट शो द ॲक्टिव्हिटी. Same with the case of strong base. If the drug is strong base, it can be undergo ionization at any pH. It may be the less pH or more pH, or the acidic pH or the basic pH. So strong acids, strong bases, the main problem with this drug is that if such drugs are strong acid or strong bases, it can be present in the ionized form at any pH, and due to that one, what happens? They undergo the ionization, and when they undergo ionization, they cannot cross the membrane. They will not enter into the blood circulation, and the activity of drug decreases. That's why most of the drugs you can find, they are not strong acid or strong base. Instead of that, the drugs are the weak acids or the weak bases. So if drug is weak acid, what happens? These weak acid drugs, it present in unionized form. हे जे वीक ॲसिड ड्रग्ज असतात ते अनआयोनाइज फॉर्ममध्ये असतात आणि जर हे अनआयोनाइज फॉर्ममध्ये असतात तर ते मेम्ब्रेन क्रॉस करू शकतात. सो वीक ॲसिड ड्रग्ज आर अनआयोनाइज in acidic pH, and when they are present in the acidic pH they can cross the membrane. So our pH of the stomach is the acidic pH. So if we are taking the drugs which are weak acids, for example paracetamol, if we are taking the paracetamol, what happens? Aspirin, they are the weak acids. So if such drugs we have taken, what happens? They remains unionized in the acidic pH which is present in the stomach, and due to the unionization they can be absorbed from the stomach. But when if they enters into the intestine having the basic pH, so at the basic pH these drugs which is the weak acids, they can undergo, there is a possibility that they can undergo the ionization. So it is difficult for the weak acidic drugs to get absorbed from the small intestine or the intestine, but they can be easily absorbed to the stomach, because in the stomach acidic pH is present, and in the acidic pH the drugs can present which are weak acid in the unionized form. The second thing is that if drug is weak base, so what happens if drug is weak base? So these weak bases drugs, they cannot absorb from the stomach. Why they cannot absorb from the stomach? Because stomach having the acidic pH, and the weak bases they undergo ionization at acidic pH. So in the stomach the acidic pH is present. So if we are taking the drugs which are weak bases, when it enters into the stomach, due to the acidity, what happens? They will form the ionization, and due to the ionization they will not absorb from the stomach. But when they enters into the intestine having the basic pH, and due to the presence of basic pH in the intestine, they remains in unionized form, and this unionized form can be entered into the circulation and it can be show the activity. So in short, the summary is that weak acidic drugs unionize stomach, so they can absorb from the stomach. Weak bases, they are unionized in the basic pH in the small intestine and the large intestine. Yes, they can be absorbed from this small intestine, they will not get absorbed from the stomach. Okay, so this is about the ionization parameter. Next part is redox potential. So what is the redox reaction? Redox reaction is the oxidation plus reduction reaction. So it is the tendency of any compound to gain the electrons or to donate the electrons. For example, riboflavin. So at the specific redox potential, the given compound shows the activity. So the riboflavin has the activity is due to the E is equal to, or the redox potential is equal to minus 0.815. Then for the quinone it is required 0.03. Then surface activity. So we can add the surfactant. So what is the role of surfactant? If surfactant is present, it can reduce the surface tension of water at very low concentration. So at the very low concentration it can enhance the rate of absorption, because the amphiphiles which are present, they can reduce the surface tension, and if the surface tension is reduced we can observe the better absorption. But if higher concentration of surfactants are present, they will increases the surface tension, and due to that the rate of absorption decreases. So what is the application? So enthalmatic activity, bactericidal activity, disinfectant activity, bile salt solution of physiological enhances the dissolution rate of poorly water soluble drugs like glycopholvine, hexastrol. It can be done with the help of micelle formation. So when we are giving the surface active agent, so in the sutics you can study detail, but when you giving the surface active agents, so it decreases the surface tension by forming a micelle, and when it takes place it causes the increase the rate of absorption. That's why these surfactants are important. Next part, protein binding. So the drugs which we are taking, they can bind to the proteins which are present in our body. So it can be albumin, it can be the lipoproteins. So what happens if they binds to the such type of agents or the proteins, the loss of these drugs can be minimized. So what happens in the protein binding? So there are two parts. If drug enters, either it will bind to the protein or it will remains unbound. Suppose this is the drug, it enters into the gut, and from gut it enters into the, or it absorbs into the blood. So if it is present in the blood, so it may present in the two forms, either in the bound form, either in the unbound form. So if the drug remains in the bound form, that is the protein binding takes place of a drug, then there is a uh, preservation of drug takes place, or there is a no loss of drug. But if drug is present in the unbound form, what happens? Drug having many types of fate. So one of the fate is that if drug is present in the unbound form, it can binds to the receptor and it will show the therapeutic effect or the side effects. So when it is present in the unbound form, or the main thing is that if it is remain in the unbound form, it undergo the metabolism reaction, so drug becomes useless. There is no use of drug if that metabolism is inactive, and this inactive metabolite is eliminated from the body. So when all these things, when it happens, when the drug is present in the unbound form, but when drug is present in the bound form, if it binds to the protein, that is the protein binding takes place, it will not undergo any kind of activity. So for example, if 100 molecules of drug, if it enters into the blood, so what happens if suppose 50 remains bound form, 50 remains unbound form? So out of 50, 25 can bind to the receptor and 25 can undergo the metabolism. Okay, so out of 100, only 25 undergo metabolism. But if all the 100 drugs, if it enters into the blood circulation and if they will not show any kind of protein binding, what happens? The 50 drugs will bind to the receptor and 50 drugs will go for the metabolism. So the number of drugs which undergo metabolism, that number increases if drug remains unbound form. So protein binding increases the duration of activity, it will increases the activity because it preserves the drug. When it is necessary, then only it becomes unbound and it will bind to the receptor. So that is the importance of the protein binding of a drug. Then stereochemistry of drugs. So drugs having different kinds of stereochemistry or the isomers if the drugs having the asymmetric center. So any changes in the that isomers or the change in the uh, stereospecificity of a drug, it will affect the pharmacological effectivity. So if suppose there are two isomers, one is the R isomer, another one is the S isomer. So this R isomer, it can show the activity, it will not, S will not show the activity. So if we know which isomer is showing the activity, it is possibility that we can select that isomer and that isomer can be converted into the form of drug so that we can give that drug. Suppose there is R and S isomer, so R isomer shows the activity, S will not show the activity, and if we don't know which isomer is showing activity, so either drug, if both will have, so if 100 molecules are present, out of 100 molecules only the R molecules will show the activity, so it will not show the activity 100%. But if we know R isomer is showing the full activity, what we can do, we can select only R isomers so that there is a guarantee that that R isomers, it will show the 100% activity. Okay, so that is the stereochemical aspects of a drug. So conformation isomer, and second one configurational isomer. So in case of conformational isomer, what is the conformational arrangement? If there is a different arrangement of atoms, that can be converted into one another, that is they are interconvertible. by a rotation about single bond. Such compounds, such isomers, we called it as conformations. Okay, so acetylcholine is the best example of this conformation, which exists in the different conformation. So it is present in the staggered form, it is present in the eclipse form, it is present in the gauge, it is also present in the fully eclipse form. So this acetylcholine can be present in the different conformations. Then optical isomers, that is the chiral center is present, so it can be the R rotatory or S rotatory. So some of these isomers, they will show better activity, some will not show the activity, so we can select the isomer of a drug which can show the better activity. So adrenaline, that is the negative adrenaline and positive adrenaline. So one is the R, one is the S adrenaline. Then ephedrine, pseudoephedrine, already we have studied. Ephedrine is the erythro, pseudoephedrine is the thrio. Then S warfarin, R warfarin. So they are the different two isomers having the different quantitative potencies. Then geometric isomers, if around a double bond, if they having the different orientation of the atoms attached to the double bond, so it called as the geometrical isomers. So suppose this carbon, one having a HL, this having the HL, so this having the, at one side they having the hydrogen, so that is the cis form. So if we remove here as the Cl, if we do it is as the H, it becomes the trans form. So around the double bond there are some substitutions are present, so depending upon that substitutions they are having the different geometrical isomers. So one of the isomer having the more activity as compared to another. In case of trans ethylstilbestrol, diethylstilbestrol, they are having the cis and trans form. So these are the steroids, estrogenic steroids. So these trans having the estrogenic activity, but the cis having only 7% activity as compared to the trans isomer. Then isosterism. So these are the two molecules. Suppose isoster, there are two or more molecules, they having the identical number, they having the same kind of arrangement of electrons, and they having the same kind of property. So the such isomers, such compounds, we called it as isosters. They must be the isoelectric. So isosterism means they having the two atoms or the two molecules having the similar kind of arrangement of electrons in the valence shell, having the similar properties, so they are called as the isosters. And if these isosters having the similar kind of biological activity, suppose two groups are there, A and B, they having the 4 electrons in their valence shell, it having the 4 electrons, they having the same arrangement of electrons in the valence shell, it having the same arrangement, and if they possessing same kind of activity, so such isosters we called it as bioisosters. So what is the bioisosters? So these are the compounds or the group that having the equal molecular shape and volume, having the same distribution of electron and having the same kind of physical properties. So they are classified into classical and non-classical. So what is the classical? If the bioisosters they having the similar kind of shape and electronic configuration with which they are replacing, they are called as classical bioisosters. Okay, for example, if we replace chlorine by the bromine, so they having the same kind of shape and electronic configuration. CH3 by NH2 by OH, so they having the similar kind of configuration, similar kind of shape. So that is the classical bioisosters. So they are univalent, that is the chlorine, bromine or iodine. So suppose RCl is the drug, so we can replace this Cl with the bromine, so they will have the similar kind of activity like RCl. So the such compound we called as the bioisosters. So these are the trivalent, CH double bond, N double bond, then tetravalents are there, ring equivalents. Okay, so we can replace. So in case of carbutamide, tolbutamide, we can replace amine by the CH3, so they are the bioisoters of each other, so they will show the similar kind of activity. In some cases we can replace OH by sulfhydryl group. So if they don't have the steric and electronic distribution as like classical, so they are called as the non-classical, so they are having a different shape or different kind of orientation, so they are having the different electronic properties. So halogens can be replaced by the ethers carbonyl group, so you can find by having the different number of electrons, they have a different orientation, the different shape of the that electronic configuration, so it can be happen in case of these isosterism. So trans diethylstilbestrol, estradiol, these are the examples of the bioisosters. Okay, so these are the factors which affecting the drug activity.